Oh, cute.
Probably best if only two of the three of us came under those,
So there's somebody
So
that
the third one can call for help.
Wait, you said this thing rolls, right?
Rolls, yeah, watch
This
this.
thing moves. Yes!
Yeah, no, I'm just teasing. It actually can roll on its own.
Okay. Brother?
Hey, sister. How you doing?
Hey, I'm doing great. Welcome back to this episode of Making It Work. We're checking back in with my brother Chad here and his EV four-wheel drive project. And tell us a little bit what you've been doing since the last time we saw you.
Yeah, well, last time you guys were here, it didn't run. We had a long ways to go. Still have a ways to go, but it actually lives. It will
does
run on its own. I'm so happy about that. Can't tell you how happy, because we struggled for a while. You know, we just to review a little bit, we talked about using the Chevy Volt battery pack, because the Tesla battery is like 850 pounds. This whole vehicle is only 1,800 pounds. That would have been too heavy, take up too much space. Can't just remove battery modules from the pack because you lose voltage. So I had to have another solution. It ended up being the Chevy Volt battery pack, 365 volts that we needed, and a smaller package and only 340 pounds. So anyhow, Chevy Volt battery, Tesla Model 3 motor.
Okay, why'd you choose the Tesla Model 3?
Well, you know, they have three primary motors they use in the Teslas these days. The S is bigger and stronger, weighs 300 pounds, but this one's 205 pounds, the Model 3.
Okay.
And it's more efficient, and it's 300 horsepower, immediate torque, like they all are because they're electric. So that turned out to be the motor of choice, and so far it seems like it's going to work great.
Mm-hmm.
All right, so we finally got it running, but not without some hurdles.
There's always a hurdle,
That
right?
always happens, yeah. I would say the biggest hurdle so far was we had everything wired up and seemed like it was going to work just fine, you know, and then you turn it on, you're like, okay, it's not working. We reflashed the computer, got the computer from EV Controls in Canada, and it's an aftermarket computer that makes this Tesla motor think it's still in the Tesla.
Oh, okay.
You know, at first, before I researched all this stuff, I'm used to building gas stuff, ICE, internal combustion engine cars. And we've built several of them in the last 3 decades. And I like that stuff. It's a hobby. And I thought, well, let's try an electric car. They're so fast. I drove a Tesla at the dealership, you know, just to test drive it, 0 to 60 in less than 3 seconds. It's like, I can't believe how fast this is. I'm either going to buy one of these or I'm going to build something with a Tesla motor in it. And so that idea came about, and finally, this is like the guinea pig. We're going to build something else later that will
Okay.
be even bigger and badder.
Maybe we'll take a peek at that
Yeah,
later.
an early model Mustang. We'll get back to that in a minute with 2 motors and 1,100 horsepower. But where was I? So talking about how we finally got this running, had some hurdles. One of the biggest hurdles was this fuse. So there's 4 of these big fuses for the high voltage side of the system. And they're really important because if something shorts out, you don't want 350 volts to burn the whole place down. That's one of the challenges with EV cars, of course. And so I accidentally shorted out one of the big high voltage wires on there. Big spark, you know,
Ooh.
in my face. And
Light up
not,
life.
you know, just like, what? Thought, hey, I'm glad that it has a fuse. Well, I replaced the fuse, thought it was going to be fine, but there are actually 2 that were blown. I didn't know that. So we tried everything under the sun to get this thing to work. After having replaced the fuse, I reflashed the computer with EV Controls, the company in Canada where we got the computer, and they worked with me very nicely. They reflashed it, changed some parameters, reflashed it again. They do this over the internet. And they say, okay, try it now. And we did that 6 times.
Wow.
Yeah. And couldn't get it going. Talking to Michael at EV West in California on the phone, this guy's really smart on all this stuff. It's like a genius. And we were talking about what could possibly be missing or wrong. And I was telling him that I'd blown a fuse. And he said, wait a minute. You said you blew a fuse, one of the big fuses? I said, yeah. He said, did you replace it? Yes. He said, did you check the others? I said, yeah, they all have the proper voltage going across them. He said, yeah, but did you check them under a load? I said, no. Why would I do that? He said, well, it may read okay until you put a load on them, and then they won't pass the current. That's what it was.
And that's what it was.
Yeah, so I replaced the second fuse, and voila.
Awesome.
Started going. We had it on the lift, turned it on, hit the gas, tires are spinning. We had a big party. We're so happy. Yeah, so that's where we've been since you were here last.
Awesome.
That answers
Awesome.
your question.
So that was sort of an unforeseen thing that you didn't really think about that being the problem. But is there anything else that
Oh,
you
sure.
kind of had to
Oh, yeah. There were a few.
make it work?
That was the biggest hurdle to get past. There were some other things, some wiring issues. You know, you try something, it doesn't work, you retest it, you reconfigure it. You know, the wiring diagram you've seen it, it's pretty extensive. There's a lot of wiring on this. When I first got into this,
I don't know.
I thought maybe, you know, you'd have a rheostat for an accelerator that would control how much power is going into the motor, and you mount your motor and your drive shafts and your batteries. How much
Easy
more could there
peasy,
be?
right?
Oh, it's crazy. There's all kinds of different computers and parts inside the motor itself, and yeah. So it was a lot of work, a lot of hurdles, but I've learned more about EVs than I wanted to know.
Would you have gone this direction if you had known?
Oh, yeah, that's a good question. I have to be honest and say, if I'd known it was going to be this difficult, I would not have started the project. I'm just being honest. But now that we're at this stage where it runs and drives itself,
You can't.
pretty exciting.
Yeah.
Now I'm kind of over the hump, so to speak,
Yep.
and there's still a lot to be done. And the battery management system has been a real challenge, and I still don't have that figured out. If anybody that sees this video knows about BMS, and we're using the Thunderstruck brand, and I've tried several different ways to make that work, and I can't get it to manage all 96 of the Chevy Volt battery cells for voltage and temperature. You have to monitor that in real time whenever you're charging or whenever you're driving the vehicle. It's very important, because otherwise there's 96 cells. If one of the cells is charging faster than the others when it's on the charger, then that cell will get out of parameter and it'll ruin the cell. It could even overheat and start a fire in a worst case scenario. So you've got to keep those batteries at about 3.6 volts, each one of the cells. And those
Seems like
3.6
that's
times
an
96.
all-time job, isn't it?
Yeah. So you have a computer system that does it, those modules over there, and they interact with each other, or they talk to the master control unit, which talks to the computer itself, the main computer, and then you get it up on your iPad and you can read all the voltage in all 96 cells. Well, that's been a challenge. I haven't figured that out yet.
Yeah, because the last time we were here, you had all the little spaghetti wires and stuff, and each one was labeled. So you're saying that each one of those has to get hooked up and monitored. Then.
Yes, and I
Each
think we
individual
mislabeled
cell.
them. I think we were off one. There's 96 of them, and I think we were one off. So that puts every one of them off, and we, put them together beautifully, soldered them, heat shrinked them. It looks wonderful. And now they're all one off, so we have to cut them all off and start.
Oh, no.
And I just don't know the configuration to get that right. And Thunderstruck, the company that makes the battery control modules, I talked with them and they said, well, we'll help you and tell us about your situation. And I said, we have a Chevy Volt battery and yada, yada. And they said, oh, we haven't done that with the Chevy Volt battery yet. I said, well, do you know someone who has, or can I find a video on YouTube? Surely someone's done that. They said, well, our system will control Chevy Volt battery pack, but we haven't done it. And so we
So
can't.
you're
tell
in
people what they
uncharted
want.
territory.
Yeah, somebody's done it. For
Unless
sure.
there's somebody out there that can help us
Yeah,
out.
if anybody knows about how to set that up, please message us or, tell us in the comments below. Send
Yeah,
a link,
absolutely.
something, because I'm really at a standstill with that right now. So I have to manually check all the cells on a random basis, periodically, just to make sure nothing's getting way out of parameter. So as I charge it slow. I can't fast charge it yet without the BMS.
Okay.
And then when I'm driving it, which I've only driven it a little bit to test drive it, you have to be careful that, some of the cells don't drain faster than the others. And if you're charging 3.6 volts is the voltage you want. So if they go to 3.8 or 3.9, or they get in a red zone where they'll damage the cells in the battery, then you have a problem.
Yeah, yeah. Hey, we are going to make sure that we link to the original video that we did in case you need to, here or in the description or whatever. But should we take a look at the batteries and stuff and this fancy charger you've made up?
Yeah, let's do a walk
all
around.
that stuff. Refresh my memory about the 96 cells. Are they all in this? Are there so many in each one?
Yeah,
You
well,
got
it's
three
a
things
full
here?
Chevy Volt battery pack with 96 cells total. Now, the double battery on the top has more cells than the two on the side. It's a bigger battery, but altogether, the three of them have 96 cells.
So there's 96 between these three
Yeah, altogether.
things, because there's one on this side too.
And they have to be managed and balanced on a regular, in real time, all the time, when it's either being charged with this big charger, which we'll get to in a minute,
Okay.
or when you're driving it. There are 4 of these satellite BMS systems, little boxes made by Thunderstruck, and they manage the batteries for voltage and heat or temperature. If it gets out of parameters, it's supposed to be around 3.6 volts for each of the cells, and if it gets too far above that or below that, it shuts the system down. We have this computer here, and they're all talking together through a CAN bus system. And if it gets out of parameters, it shuts it down.
So these should be attached somewhere in here to.
Yeah, they're going to sit on top of each battery like that. There's 4 of them. And then we have a battery cover.
Yeah, because I was wondering, it looks like a lot of stuff that shouldn't be touched.
Yeah, so we want this to be really safe and secure. I used the original Chevy Volt platforms that the batteries come on. I got that whole battery kit from a wrecked car.
Yeah, because I've seen you roll things.
Yeah, that could happen. I mean, we're going to race it, so yeah, it'll probably roll over at some point. Anyway, this goes on top of that battery, if you can imagine, all the way down in there. And it fits tight on top, and it's even waterproof. So that's how we make the battery pack even safer. But managing it has been the challenge here lately. And where'd my little box go?
You just.
On top of the battery.
There it is.
That could be part of the problem.
Yeah, it's a lot to remember.
There you go.
So anyway,
It's probably good for our brains to keep them active.
this has been a real challenge, and if anybody watching this video knows about either Thunderstruck or just BMS, battery management systems in general for Chevy Volt battery pack, I need help with this. This has been the biggest struggle of the whole build.
Oh,
I thought it was going to be just getting it running, and I mean, there is so much to get this thing to make this Tesla motor think it's still in the Tesla. You got your aftermarket computer, you've got a pre-charger, which has a resistor in it, and
why do you have to make it think that it's still in the Tesla?
because Elon Musk is really smart, and he made this system so that it would be safe
Just email
and
him.
effective, and I have emailed him, and he said he's going to come and help me once I get a little
Alright.
further along in the process. And actually, the next project, that's going to be a Mustang with 1,100 horsepower and 2 Tesla motors. So, but yeah, when he comes for that, I'll see what he thinks about this as well. Yeah, in my dreams.
Right, yeah.
He's one of my heroes, but
There you go.
we're not on like I don't have them on speed dial or.
Okay.
All right.
Oh, gosh.
So the batteries, once we get the BMS working and all that, then I can use the charger to its full capacity. So there's
Yeah, tell me a little bit about this
Yeah.
thing.
3 high capacity chargers on there. They plug into 220.
They're so shiny.
Yeah, it's a lot of charge. Or in this case, I can plug them in one at a time to 110. So that's what I've been doing just in this testing stage because I don't have the BMS system working yet. And I don't want to overheat the battery pack or have some of the cells get charged faster than the others. So I have to manually check them with a voltmeter until I get this BMS system working.
Yeah, I was wondering about like EV cars. I've not been around them much. How they charge and stuff. You just plug them right into the wall outlet in your garage, or how that works. But
Well, yeah, we have a special outlet over here in the shop, and we use it for the welder. It's a 220, normal 220
Okay.
outlet. And I think, here it is. Yeah.
okay.
And that hooks all 3 of these in at one time with 50 amps and 220. And then we have this to go with 3 into 1. And this hooks on here.
Oh wow,
Yeah,
it's a big system.
yeah. And so we charge it that way. So right now I have to charge it really slow until I figure out this BMS system.
Gotcha.
I even had a friend, Ben Myberg, he flew in from South Carolina, and he works on electric planes and motorcycles, electric motorcycles.
So he knows what he's doing.
He's a genius with this stuff. And so together we got all the systems working so far, except for this BMS. Neither one of us have been able to figure that out yet, the wiring for it.
And what's your little taped on system here?
That's a pre-charger, and who would have thought you'd need a pre-charger, but what it does is it takes the 365 volts that the Chevy Volt pack puts out, and instead of snapping that motor with 365 volts all at once, it slowly gives it power through the pre-charger. It's like turning on a light bulb. You wouldn't just flip the switch, you'd use like a
It's like a
dimmer.
soft start.
Like a dimmer for a soft start, exactly. And, I just read that that was important and that it would ruin the motor.
I was gonna say, that's gonna help save your
The motor itself.
life.
Yeah, it's actually the electric motor, it doesn't care, but all of the computer
Gotcha.
workings inside of it,
Gotcha.
which are substantial. That's half of the motor. The motor's about this big, it's 205 pounds. Half of it is full of computer stuff. So it has to be amped up slowly.
So that's some stuff that you're still working on. What about these shiny things right here?
Well, that's rear steer. So,
So it's
We have-
already set up for rear steer.
yeah, we put rear steer on maybe 4 other race cars that we've built over the
remember it.
years. It's so wonderful in a racing environment. If you're trying to get around some kind of a course that's tight without rear steer, sometimes people have to back up. And if you have to back up
Do a
on a race
10-point
course, you're
turn.
not going to win.
Yeah.
So you can just spin around and go the other way. So set it up when we built this chassis. Originally, Todd Minner, a good friend of mine, we built this together with his tubing bender, which is over there in the corner, just the regular welder we have here. We bought a truckload of tubing, made all of this. Todd's a genius with this stuff, and he teaches welding classes, so the welds are, which thrills me because I like beautiful welds. I only welded in the places where you can't see it very well. Todd did all the places
He
that
did
were
all the good
important.
stuff.
Anyway, we built these A-arms and everything from scratch, pretty much the whole buggy, and set it up so that these gold-colored tie rods can be hooked to a electric rack and pinion for rear steer. So we haven't done that yet. That'll
It's
be
one of
after we get
those-
everything else
yeah,
working.
Yeah, when it's working.
Yeah.
Once you get the battery management system figured out. Okay.
Yeah, the BMS it's got me stumped right now, but
I hate
the
that.
show must go on, so we'll have to figure it out somehow.
Like most steering is
Hydraulic?
hydraulic.
Well, in this application on an off-road racer, oftentimes we'll use hydraulic steering. It's stronger. You don't have as much feel for the road or the track you're on because there's a disconnect between the driver, the steering wheel, and the hydraulic lines and all that. But in this case, hydraulic's not really a good option I've done that before on a few, hydraulic over electric steering. We're going to use just pure electric. So it'll be a rack and pinion right here that'll hook to these two tie rods.
And have another electric module basically on it.
Yeah, it's electrically powered, no hydraulics.
Interesting.
And I do that with the front already. It's got fully electric power steering. That's pretty common in some of the electric cars, even the ICE cars now, internal combustion engine, ICE.
Ice.
You asked me if that was like fill the cooler with
Fill the
ice
cooler,
or what?
yeah.
So,
Oh, goodness. Got little ice makers on
not really. I like ice cars, don't get me wrong. I only built this thing because I hadn't really tried EV before. We built several other ice cars.
Yeah, because the sound of this is not like.
No. Well, it's really, I'll take you for a ride and you'll see.
Okay.
I mean, I love the sound of a really strong V8 motor as much as
Yeah, I
the
do
next
too.
guy or gal. But, and I'm always going to love that. I mean, if you look around the shop here, we've got some cool, fast ice motors in our vehicles, gas motors. But when you get in this thing, you can hear the air rushing by. You don't hear the motor. I kind of miss that, but I kind of like the change.
Yeah.
And you hear the tires on the pavement or on the track. You hear mechanical things happening that were really drowned out by the sound of the motor before. Most of the things we have are kind of loud.
Yeah, when I hear stuff in my car that I'm like, ooh, what is that? I just turn the radio up.
Yeah.
That's how I fix a lot of stuff.
Yeah. Well, it works for a while until whatever's making the noise screams louder and breaks. So anyway, it's pretty cool. It's hard to describe, but when you floor it and you don't hear the motor scream, but you just shoot
you
off
can
like a
feel it.
rocket. Yeah, it's pretty cool. And I'm starting to lose my hearing. I'm right on the edge of needing hearing aids.
Oh,
My
man.
wife's been asking me to get them for years.
Well, and our dad has double cochlear, so that's
Yeah.
probably some of it.
Yeah, a little hereditary stuff. So,
Yeah.
so anyway, not having that loud motor. I like shooting sports and
Yep.
motorsports. So this will take, this will be helpful for my ears.
Exactly. All right, is there anything else that you want to tell us about? Anything that I know you've got a whole list to check off yet of things that you need to do, but.
Yeah, well, obviously it's not finished yet. It's just at the stage where we can test
We can
it, run
use
it up
it.
and down the driveway, that kind of thing.
What about tell us a little bit again about the drive shafts, because I know that you've said
Yeah.
you've turned that Tesla motor.
So the Tesla Model 3 motor comes, it's called a transaxle in the back of a Model 3 car.
Uh-huh.
And the output shafts go to each wheel, much like these shafts are going out to the wheel. But in this application, I took that Tesla Model 3 and turned it longitudinal
Okay.
in the vehicle so that those shafts now power the front differential. One does. The other one powers the rear differential.
Okay.
And thereby we have four-wheel drive with just one Tesla motor.
Gotcha.
I thought about putting two motors in with this 1,800-pound vehicle. That would have been overkill, too much weight, too much to deal with, way too much power. It would just spin like a little RC, which sounds good. I mean, it's still going to do that. 300 horsepower immediate torque in this 1,800-pound vehicle.
Right.
That would be like having 600 or 800 horse in a
Heavy.
4,000-pound Mustang,
Yeah.
for example. Twice the weight.
What about how do you keep it cool?
Oh, yeah. So cooling on this thing is not really a challenge. That's easy enough. I'm going to do that in the next day or two. I've got it all lined up. Bunch of tubing.
Uh-huh. This looks like water hose.
Yeah, it's like heater hose, 3/4 inch ID, reinforced hose, and a bunch of fittings. And really,
So there's just going to be like fans.
there will be a radiator and a fan that'll sit about right here.
So there is a radiator.
Yep, a small radiator. There's not as much cooling required as an ICE motor would have. You don't have internal combustion.
Right.
And so there's really just the friction from the parts moving
Okay.
and then the heat that the batteries generate. And so you run cooling through each of the 3 battery packs. They have little tubes on them. just for that from when they were in the Chevy car. And you run your cooling through there, it filters through the batteries to cool them, and then you also run it through the motor itself, and it has a heat exchanger on it for the oil and the differential on the motor. So the motor has a differential that splits the torque in two directions, and it needs to be cooled.
Okay.
Yeah, so,
That makes sense.
yeah, so I'll do that. I mean, that's just common sense and some engineering. It's not like the BMS that has me stumped right now.
As you're getting closer to the end of this build, is there anything that you would change or do differently? Because, I mean, we all know we're thinking about that next build and stuff as we're finishing up one, but is there anything you would...
Well, I don't know if I would change so much on this build itself, but this is really the guinea pig for the next project that I'm
So you are
even
already
more
thinking
excited
about your
about.
next
Well, you know
project.
how it is, yes.
Yeah, we do know how it is.
So the next project will be a early Mustang, 65, 6, 7, 8, something there, probably 60, 65 or 67, I suppose. I like those. And
Yeah, I remember you having one.
yeah, I did. I had 68 actually when I was 17, 18, and wish I still had it. So the thing is, I want to put two Tesla motors in it from an S car, which is a bigger, faster motor than the 3.
Okay.
And it'll be about 1,100 horsepower total.
And just, why would you put 2?
All-wheel drive, this is the most efficient way to get four-wheel,
Four-wheel.
all-wheel drive in this size vehicle.
Gotcha.
But on a early model Mustang, I think having one rear drive motor and one for the front. Now, I'll use the entire Tesla drive units with suspension and brakes and everything on them.
You will.
Yes.
Okay.
And we'll use a boxed aftermarket frame for a 67 Mustang, and it'll be a lot stronger. Because if you put 1,100 horsepower into one of these 1965 framed original cars, it's going to twist it up. It's too much power.
Too much power. I
Yeah.
didn't know you could have too much power. Did you know you could have too much power?
No, but it's true. You could actually. And so we'll buy the box frame, and then we'll build everything around it. You can buy the panels and interior and just everything. You have to fabricate a lot of it. but
Yeah,
you can buy
I'm sure,
most of
I'm
that
sure.
stuff new. That way it'll be strong enough to hold that much power. And then traction control is an issue because if you have that much power and you floor it, it's just going to burn the tires right off of it. So it uses a GPS signal and measures the speed of the tires in relation to the front to the rear and how fast you're actually going.
Awesome.
And then it keeps it from just spinning so fast.
That is amazing stuff.
Yeah, it's important. It monitors it like, I forget how many times per second to make sure it's not just spinning out of control.
All right. Well, hey, speaking of old Mustangs, you want to tell us a little bit about this one that's sitting over here?
Yeah, sure. So that's actually not mine, that's Parker, my son. He lets me drive it once in a while.
Oh, well, hey, there's that.
And those things came with about 240, 260 horsepower in a 289 version.
Okay.
And so we're talking, and his is souped up, it's got quite a bit more than
Yeah.
that. But we're talking about putting two Tesla motors in there with immediate torque and 1,100 horsepower. It's just a crazy amount of power and a wonderful project and a difficult project, but it's a
Is
challenge.
this one, you said this one is souped up, it's not
This one's
stuck.
souped up, but it's going to stay what we call ICE motor, again, internal
Okay.
combustion engine. We like those too, of course.
Sure, sure.
And then the next one will be built from scratch with Tesla motors.
Okay.
Yeah, and Tesla batteries. Use the Chevy Volt batteries here because that was the best option.
Because of the weight.
The weight and the space limitations
Yeah,
here.
yeah.
So the Mustang will have the Tesla batteries as well. And it'll need that with that much horsepower. So as we're looking at the underbelly of this thing, obviously there's going to be skid pans on here. Here's a skid. This is
Okay, just to kind of protect everything?
This is some thick plastic
that I like to use for skid plates.
I
But
thought it
back
was
here
metal.
where it matters more, underneath the engine and the brake rotor and so forth, that'll be 3/16 or 1/4 inch aluminum. And I've put all these tabs in here already so that that aluminum can be held
So
tight
this
in
is your
place.
welding versus,
That is, yeah, I love
it
that.
doesn't look too bad.
No, it's not bad, but it's not quite as pretty as what Todd does. So, yeah, so this whole thing will be covered with skid plate when we get it back together. It goes from a CV shaft here out of the Tesla motor, and it converts from CV on the shaft to a U-joint and a yoke at the other end. So I took this tube, this drive shaft from a 2002 Ford Expedition and modified it and then mated it together with the Tesla output CV shaft. And I had to sleeve that and it's got to be tight and straight, and it works really well. And this back one, this back drive shaft, there's your CV coming out of the Tesla, and then it goes to the yoke, and it turns into a U-joint set up on the other end. I haven't really tried that before, but in theory it seemed to me it would work, and sure enough, so far it's working pretty good. There's your brake rotor, caliper, your differential.
So you can't do a donut with this then?
Oh, yeah. What do you mean?
Because you can't break the front wheels as you're
Oh,
spinning
you
your
don't
back.
need that. You have enough power. You don't need brakes. All right, so now that we fired this up, we have several different things we can monitor on this gauge. We've got high voltage here of 350 volts. That's probably one of the more important things to me. Knows, I want to get it at 365 is about max, so we're not far from the max. I can choose how much regeneration of braking we want. It's at 70 right now. Accelerator pedal, if I could reach it, if I push it down, that would go from 0 to 100. It's in neutral, so it'd be safe. If it was in drive, it would shoot through that wall over there. And all the different things, inverter temp, stator temp, PCB temp, whether the brake switch is on or off. Now, if we had limited slip, because we had two motors, there'd be a limited slip measurement here. Whoops. GPS, hooks to GPS to do the limited slip. And then we have other things we can do. Like we can set, for example, if we scale the speedometer, we can set that. Max power, I've got the power down at about 1/3 of maximum, and it's still really fast already. I just don't want to take a chance on blowing up the diffs or something because it's a lot of power. Maximum regen is 69. Cooling fan temp comes on at Celsius 42. Max speed, you can set a maximum speed if you want. And minimum.
But we don't want to.
Well, we do, yeah. We don't want to go much over 80 because you can die if things go wrong. And then you can die at 40, really. And then you've got minimum high voltage pack voltage. I set that at 255. As you saw, it's like 350 something right now. So it would actually, the batteries would get down quite a bit lower before it would actually stop us from being able to drive it. And that's maybe a little too low, but you can adjust it according to whatever you want. And there's all kinds of things in here you can do that I haven't even experimented with yet.
That's pretty cool.
Yeah, lots more things. I'm afraid to mess with it too much because it works right now, and if I said something wrong, it won't work, and so we're going to enjoy it.
All right, let's take a ride.
Yeah.
Oh. Take that right off.
Yeah.
Snarled your necks.
Okay, now if I remember stories from the past, Chad say, just stand still. You'll be all right.
Mom.
Don't tell Mom.
So.
Let's not have a don't tell mom moment.
So what's really weird about this is you can actually video and record and actually drive without the noise of the motor taking over.
That's
So
right.
I'm going to give the iPhone to Amy and she's going to hang on to the iPad.
Now, make that click in the right hand.
Okay. It's clickied. What?
Sure. Yep, you're good.
So
All right, so
There we go.
we are going to put it in reverse. You're on it.
I'm good.
Okay, reverse. And here we go.
Oh.
I didn't even hear the motor start.
Me neither. Ooh, great. Uh-oh. What was that?
All right, that's just the locker.
Oh, okay.
Now we put it to drive.
Hang on.
We get, hang on. You ready?
Oh, sure. Whoa. I see what you mean about the instant torque. I better hang on. What did I hang on to?
You're hearing the gravel, you're not hearing it.
Yeah. That is interesting.
Rolling? Did you hear your tires?
Okay. Let her rip, Peter Tip.
Are you ready to go fast, Amy?
Let her rip.
How fast?
I don't know. I don't want to take flights. Makes my lips stick to my teeth. No, he said, no, don't tell moms.
Yeah, don't tell Mom. That's if we took over.
Yeah. Wow, that was quite a ride.
Yeah, it sure was.
That was great.
What do you think?
I really like the suspension in it. The bumps and stuff is just super smooth, super, and like better than a car, really, for what we were doing. And yeah, you definitely could feel that. You could feel that power. I see what you're talking about with that.
Yeah, that was
That
only
instant.
about a half of the power it has.
That's all.
Yeah.
Really?
I mean, you can set it up to only do 50%, and that's where I've got it at right now.
That's something. That's something. I can't imagine if it was all the way
Yeah, we're gonna find out.
up there. But,
Makes you smile big.
I like it. Yeah, that's the first time climbing in and out is a bit of a chore, but it wasn't as bad as I thought it was going to be. And yeah, it was fun. I think I was watching the speedometer. And I think we topped out at about 69, just on this little short strip of driveway.
Yeah.
So it's cool. It's cool. Thanks for having us over and letting us see what
You're welcome.
you're doing
Shaking
here.
hands?
I know.
Well,
Thanks for letting us see what you're doing here and thinking about your next projects and all that good stuff. And thanks for watching this episode of Making It Work. And please like and subscribe, send it to your friends, hit the bell buttons
and
and,
if you know
all the
anything
stuff.
about BMS, send us a message. Battery Management System,
I know
Thunderstruck.
what that means now.
Yeah.
And ice. I know what
man.
ice means now
Yeah.
too.
What? Cooler ice?
Internal combustion engine.
There you go. You got it.